Yeah, so again, I'm Will Farrington. I do work at GitHub on the operations team. A man with many job titles. It's actually kind of funny. The reason I ended up with that really long job title, we have this kind of internal Twitter-like thing, and everyone has what they call a role, like in the organization. The only rule is you actually can't set your own. So everyone sets everyone else's. There's been a bit of an escalation going on between me and a few other people. We made Mark Imbriaco a cloud architect of some sort. I don't know. There were a few other words in there. And I ended up with junior executive assistant to the assistant VP of operations. Yeah, it's a mouthful, right? It almost sounds like a real job title. So anyway, I'm here to talk to you today about Puppet at GitHub. Obviously, we're big Puppet users. We've been using Puppet for a long time. We got a really big code base. We've actually got 2 code bases. Let's talk about that. So what is the state of Puppet as it stands now inside our organization, right? Well, the first one, which I'm going to be talking a little bit more about tomorrow, is Github Box, and we're just going to run through this real quick. It's about 1.5 years old internally right now. It's pretty awesome. It was open source 7 months ago, so back in February when I was in Australia for RubyConf Australia, we open sourced all of the core components of that. Since open sourcing, there are about 240 open source Puppet modules now, designed specifically for use with Boxen, that are all available on GitHub. It runs on Puppet 3.latest, supports Ruby 187, 193, and 2.0.0. Highgroove first is kind of the big focus for what we've been doing a lot of the stuff with Boxen recently. The whole idea being is that we have a lot of people using it now who really aren't even, they don't understand Puppet. They haven't written Puppet before. And it's all about lowering the barrier to entry. So we're starting to use Highgroove for a lot more of this stuff. It's used for configuring OS 10 machines. And I'm happy, I'll talk about this more tomorrow, but we're actually completely set for OS 10.9's release here when that gets released publicly, probably in the next 3 to 4 weeks. Linux support is in progress. That's just kind of like the overview of what's going on with Boxen. We're going to talk more about that tomorrow. I have a session. That time's actually wrong. I believe my session is at 3:10 tomorrow, and it's in the sort of product track. But what I really want to talk to you about today is GitHub Puppet. This is what we use to manage our production infrastructure, our office infrastructures, these sorts of things. So let's start with a few numbers. I always like looking at all sorts of graphs and sort of metrics that we can collect around what it means, like how the code base is actually being treated, right? So again, it's a 5-year-old code base, right? So nearly. I believe it was September of 2008 when the first commit to what was then a Subversion repository, who'd have thunk it, to start building out GitHub's Puppet infrastructure. In that time, we've moved from 0.24x releases all the way up. We're still on 2.7. We'll talk a little bit more about that later. Our current code base is comprised of 121 individual Puppet modules, which come out to about 280,000 lines of code in our Puppet code base. And that's just the current working tree, of course. We've had lots of stuff added and deleted over time. If you look at the entire history of Git, it comes out to somewhere around 500,000 lines of code in the course of this repository's history. Another thing that's kind of interesting about our code base, I think, is that every single employee at GitHub has access to it. I know this is pretty uncommon for a lot of organizations, especially as you start to get more and more employees. But yeah, every single one, they have full write access. You know, they can commit to master. That's totally acceptable. They might get chastised if they break something, but they're allowed to do it. In the past year, we've had 15,500 commits on the code base. But I think the more interesting thing is not the number of commits, but rather the people doing them. We've had 86 people inside GitHub contribute to the GitHub Puppet code base in the past year. Now, the current size of our company is this. That's 202 employees as of yesterday. What that looks like in terms of a breakdown, 42.5% of our company has worked on our Puppet code base in its history. Now, where it gets really exciting for me is if we take out the operations team, it still looks like that. We have, you could argue 12 people who work in operations at GitHub, and yet we have another, 74 people inside the company who touched the Puppet code base in the last year. That's kind of exciting. Let's look at activity. This is a pretty fun graph. So this is the last 12 months as well. You can see sort of the breakdown. We start kind of the beginning of 12 months ago. around 100 commits a week across all of our contributors. You can see we have some big spikes, but what's really interesting there is the sort of exponential growth curve, right? So it's projected growth based upon varying degrees of exponentiation throughout the graph. And you can see we've climbed now from 100 to almost 300 commits a week in terms of that exponential sort of moving graph average. And the thing that excites me the most is we've actually brought on a lot of operations people recently to our team, and I expect this number to go up. Really, I expect it to hockey stick a lot at the end of the year. I'm thinking right now, based upon this graph and how many people we've hired, we're probably going to be hitting about 400 commits a week on the code base by end of year, which I'm really excited about. But let's look at who's doing the most, right? So this is total commits by author. It's kind of a long tail. You can see like there's a lot of things you can't see at the end of the graph there, right? So let's go ahead and take out the operations team, because we kind of inflate the end of the graph a little bit. So it's looking a little better, right? With the operations team gone, we've got some folks almost 700, 500 plus commits in the last year. That's not too bad. All right, well, let's take out the people with less than 10 commits. OK, we're getting a little bit more respectable graph. It looks like our sweet spot, if we were to take a really naive average, it's about 100 commits, right? That's pretty awesome to me, I think. Not a lot of people have that sort of contribution rate inside their companies when it comes to their Puppet code bases by people outside of operations. So our setup is really simple, actually, like a lot of things. We use a single Puppet master still. We have one box, one bare metal machine now. It used to be a VM until like 6 months ago even. We use Ruby gems to install Puppet. We don't use Puppet Enterprise. We don't use any of the operating system packages. We just install Ruby gems. We're still running on Ruby 1.8.7, which you can imagine is the only option, really, because we're still running on Puppet 2.7. We use Unicorn as our application server. Zero downtime restarts are kind of nice. Like I said, we're running Puppet 2.7. We're about 600 nodes right now. And that's a mix of predominantly bare metal machines, but also some virtualization involved as well. We still run Puppet hourly via cron. We don't use Puppet Agent. We don't only kick off runs when we need them. It's all sort of focused around the idea of just letting cron do it once an hour. Now, that said, we don't run everything on exactly 0 minute. It's a terrible decision. You're going to kill your Puppet master if you do that. But what we do is we actually splay. It's a really simple sort of pattern. We just hash the host name, and then from there, mod 60. So then you get a sort of uneven, naive distribution across all the minutes in the hour, but it keeps your Puppet master from being overwhelmed. Really simple pattern. We're also using a lot of PuppetDB right now. And we've written some tools sort of to embrace what PuppetDB allows you to do. And these have made our lives way, way better. They've made a lot of our developers happier, and they've made a lot of us happier as well. First one is NodJosDB. This is written by James Fryman. He's somewhere here in the crowd. And it's a really simple concept, right? So it's a little script. It's just written in Ruby. It's like less than 100 lines. All it says is, yo, NodJosDB, I heard you have some like Nodjos configs. Can you hook me up with that? And it sends them down, and we just render them into files. And then we tell Nodjos, check the configuration. Does it pass? If so, update the monitoring configuration. We also have something that I've been working on a little bit today, actually, called Filtergendb, which is the same sort of concept. We use Filtergen to manage our IP tables rules. And again, it's just like, hey, NodJosDB, why don't you give me a whole bunch of things, and I'll take care of it. Now, the reason we do that is pretty simple. It's because PuppetDB is fast, right? It's way faster than a Puppet run. As it turns out, a single API call to a remote service is probably faster than your average Puppet run, even when you have a node like ours. So our monitoring server, for example, has about 400,000 resources on a single box. Because it collects, right, one resource for every single Nodjos service you have, for every host group, service group, contact, all that stuff. It's all represented by a single resource. And Puppet runs, for us, when we were doing it all inside Puppet, would take, even with PuppetDB, up to an hour. With this script, it takes about 40 seconds to update the Nodjos configuration instead. We've also been using a tool that we wrote internally called gpanel. Gpanel excites me a lot. If someone asked me to describe it, and this is kind of what I could come up with, sort of if I had to make it just like really vanilla, not worry about like what we talk about inside of GitHub. So it's got a lot of elements that were in Puppet Dashboard, a lot of elements that were in Razor, and it's got a lot of the sort of niceties that it exposes to developers that you see in things like the Heroku ABI. We did reinvent our own version of Foreman. Sorry, Sam. But that's kind of OK. We had some special use cases, and we had some things that were legitimately difficult to do within the existing infrastructures provided by Foreman and Razor and Puppet Dashboard and these other tools. So what does PuppetDB do for us? Well, the first thing it does is inventory. That is to say, we capture things like hosts, cabinets, we capture our switching, all that stuff lives in some form in this database represented by this application. It's not very exciting. A lot of people can do that. It's really easy. Most of you probably have something like that. Where I start to get excited is when we do things like this. We have app configuration at a very high level, very Heroku-like. Our developers are loving this. This is really new. It's past month or so. And they're just going absolutely nuts over this. And what it looks like is like this, right? So we're in chat, and I can say, hey, I want to set the config for my application octo status. And I want to say that super cool is 1. I want to do it in staging. You do it from chat. Qbot will safely lock the room, set the setting, unlock the room. The cool thing, though, is you can also ask for a config back. You can look at the current config. And again, he's going to lock the room beforehand and unlock it afterward. We're not leaking secrets this way. We're not storing secrets in code bases. And it gives you sort of a lot of the niceties that, for example, the Chef crowd has with encrypted data bags and stuff like that. We have an encrypted storage for this, and it's all locked. It's never logged anywhere. Allows us to keep our secrets out of code. It vastly simplifies a lot of things. One of the other cool things built into this configuration, though, is the idea of versioning of configuration values. It's really simple. You can see the entire history of a configuration value. It makes it really easy to audit when things break, when people set these configuration values. It's kind of nice. It also makes credential rolling a lot less awful. I don't know what your guys' internal processes are when it comes to having to roll production credentials because an employee has left the company. Ours is really hard right now. This is a good step in the right direction, and it's a tool that we like quite a bit. One of the other things that gPanel is responsible for is provisioning. Now, I mentioned previously that provisioning for us, like we have a lot of bare metal. We don't use a lot of virtualized infrastructure. We don't use a lot of the public cloud. And provisioning when it comes to bare metal is pretty bad. I don't know when the last time you guys looked at it is, but it's not an elegant process, especially if you don't want to hire people whose full-time job is to sit in the data center and rack and stack and configure boxes. So we sprinkled in a little bit of chat ops and a whole lot of automation, and we came up with something that looks like this. This might be a little bit hard to see because of the letterboxing, but this is me in chat actually telling Qbot to install a host. Now this host, I've never touched it physically before. It's been put into a rack and by the data center, and it's had some networking cables plugged into it. From there, it was able to boot up using IPMI.dhcp, so we're able to get to the IPMI interface. It boots into a memtest image, memtest for an hour, reboots into a break-in image, does break-in for a full day, then reboots into a ready image that we have a full console on we can SSH to, sits there until we're ready, and then when this installs, this will go through, hit our pre-seed image, come up, do all the post-install and configuration, reboot the machine for final changes, and we're done. It takes about half an hour, which is not bad. We're still trying to make that better. So a little bit later, after I run that command, I get a machine. Qbot's like, here's the IP. Here's how you can get at it. All my SSH keys, all my configuration is already there. Well, we also use gPanel as an ENC, external node classifier. One of the cool things I like about our particular implementation of this, though, is I think we have the dumbest ENC possible. Like, it's really a terrible ENC for a lot of reasons, but I absolutely love it. I think that makes it really special and helpful in its own way. This is what it looks like when we actually use it. So we have a script that makes an API called a gPanel and writes a local cache to disk, so when gPanel is unavailable, we can still get our ENC information. One of the things you'll notice right here, there's only some parameters, and it's very simple ones at that, which is to say that we never specify classes with our external node classifier. We've talked about this a lot, and we really couldn't come to a good conclusion as to why you would actually want to do that in practice with a lot of nodes. It tends to cause a lot of trouble and really confusing behavior when it goes wrong. You'll notice we also prefix any variables we pass through with gPanel underscore. We don't try to clobber anything in the top level namespace. We isolate it entirely, and this works pretty well. So how does GitHub actually write Puppet day to day, right? That's kind of what our infrastructure looks like at a 10,000-foot view. How are we writing Puppet? First thing is, use Puppet-lint religiously. You can go to GitHub, you can get it here. It's written by Rajek. He's also hanging out in the room somewhere. And to be honest, if you aren't using Puppet-lint, you're kind of doing it wrong. The reason for this is the Puppet lint enforces the style guide that's declared by Puppet Labs, right? This is officially from on high the ideal way for you to write Puppet, and Puppet lint helps you do that. You should be using Puppet lint. And one of the cool things that a lot of you might not even know is that Puppet lint can fix a ton of errors for you. There's a whole class of errors that Puppet lint has the ability to automatically rewrite your code to fix known linting errors for you, so you don't have to spend time doing it most of the time. So what we did, we put it in a pre-commit hook, right? We're using Git. I'm sure your other version control systems can do this too. And what it looks like is this, right? So I go to commit some changes, and I made some changes to this file, and it's going to go ahead and lint it and say, hey, sorry, that's not, you have a misaligned arrow. You're a terrible human being. Go fix it. Then you can commit again. And then once you do that, and you realize how amazing it is, you should go buy Rajek a beer. The next tool we use, RSpec Puppet. You'll see a trend here. Also written by Rajek, still available on GitHub. Again, if you aren't writing tests for your Puppet code, you may in fact be doing it wrong. You're testing in production, man. That's cowboy coding. We all argue that it's a bad thing when developers do it, but we're often really guilty of it ourselves. I don't care which framework or library you use, actually, as long as you're testing. There's some pretty cool stuff coming out of the Chef community, to be honest. Test Kitchen, I know has Puppet support now. I'm not sure that's the best implementation, but it's a really amazing idea. There's not a lot of support out there for integration testing and acceptance testing of Puppet modules right now. RSpec Puppet's just a pretty good one. It's what we use, and it's pretty well maintained. So again, put it in a pre-commit hook. Then you can do stuff like this. Single C thread. And then you can buy Rajek another beer. So let's talk about node definitions. So again, I said we don't use the ANSI to actually describe any of the node classes themselves. We just use variables. So what does a node definition for us look like? Well, of course, they're all flat files somewhere in the repository. And they look a little bit something like this. So we have some pretty hard and fast rules. You have a GitHub role, right, of some kind for your server. You have a high-level class that encapsulates all of the information about that node, and that's it. We don't put other stuff in any of the node definitions. It's a quick way to get an unreadable mess of code. More importantly, you'll notice we pass through variables. Any top-level variables we want to use, we typically try to pass through as parameters of the actual role that we're doing. So in this case, a polling Redis node, we're using gpound to determine whether the node should even be enabled, so whether it's actually running Redis and available to take in requests. We use things like gpound to configure the environment, whether it's in staging and production, so on and so forth. One of the other things we focus on is writing abstractions as far down as we can, right? So the way I like to think about this is almost taking a CSS-like approach to writing your Puppet, which is to say that you should think of it like a cascade, right? So you have your site classes, your most specific thing. So GitHub role polling Redis, right? And then from there, you have options that cascade down to another implementation, which might be the default sort of implementation of what Redis looks like in the GitHub context. And then from there, it cascades down into sort of the generalized implementation of what a Redis server looks like. As long as you pass these things all the way down, you end up with very readable, very robust code, and it's reusable. So in our case, what this might look like, we have that Redis server class. We're going to go bottom up. We're going to walk up the cascade, right? So we have some config, we have a package, we have a service. Take some parameters, and they all get passed through. And then if we bubble up a level, we get to GitHub Redis, which pulls in some GitHub default settings, sets some things like, for example, the default memory that a Redis instance on a box might get, and then calls down to Redis server. And then we have our higher level role, which is the polling Redis, which may have GitHub Redis, but is probably going to override some of that behavior based upon its specific use case. We're also big users of Augeus. Augeus is actually one of my favorite tools, and it really doesn't get enough love. Because you know what's not awesome? Well, there's a lot of things that aren't awesome, but what's especially not awesome is having like these massive ERB templates and having these classes that take a bajillion parameters so that you can set like every individual line in a really long config file. And a lot of people try to get around this. They use things like the concat module, which is an OK workaround, but that's all it is, right? It's not really fixing the problem. It's putting a really big Band-Aid on it. Eventually, things like that start to break down in a really bad way. So use of Augeus makes these things a lot nicer. We do a lot of things like this, for example, right? We have an entire MySQL configuration class that's basically a giant chunk of this. We do that like sort of per role. And it works out really, really well. It could seem complex and scary at first, especially if you want to write your own lenses, because there's a particular file format that doesn't have a lens that supports it. But it really is an amazing tool, and you should check it out. So let's talk about how we're shipping Puppet, right? How it actually gets on the servers. We're big fans of continuous integration, obviously. So the basic idea, commit gets pushed, Jenkins runs the test suite. Eventually, the commit status API in github.com gives you a little green bubble on your pull request. And hey, the tests have passed. What's unique about our setup, I think, is how we do some of the things there. We're big users of this gem that was written by Aman Gupta, TMM1. Works at GitHub. It's called TestQ. You guys might have used parallel test or similar sort of tools before, which take a very naive approach to how they parallelize things, which is to say, I have n many tests and I have m workers, and I want to go ahead and split them up roughly evenly, and it's going to run the test. But what happens if you have a really, really long test, right? What happens if you have a disproportionate sort of number of cases in a single test file? It's not a really optimal sort of distribution of things. So you can go to GitHub, you can install this gem, and the cool thing about TestQ is it actually remembers the time that each test case took. So when it distributes tests to each of the individual test workers, it distributes them so as to equalize the amount of time possible. So what this does is it allows you to get the single fastest time that you could get parallelizing all those tests over subsequent runs, right? So it's kind of a learning behavior. It knows how long each test is going to take and can then optimize, say, OK, we can get this down to 60 seconds. We have a whole ton of specs in our Puppet code base, and it takes about 60 seconds, where before it took minutes and minutes and minutes and minutes and minutes. You should check it out. We're also big fans of continuous deployment, right? So it's the whole idea, test pass for commit, Hubot or something else is going to auto-deploy for you. Nothing really exciting there. What we do that's a little bit interesting, I think, is that we branch deploy everything. I know it's kind of common, right? So for a lot of shops, you have a few environments. And maybe they look something like this, right? You've got 2 or 3, maybe 4, if you're getting a little adventurous. So I looked today. I want to see exactly how many we had. We have 181 environments currently on our Puppet Master, which is interesting. So we have 181 environments, but that's not the same thing as saying we have 181 nodes running those environments. We actually don't. I also checked this one out because I figured someone was going to get real angsty about that. We only have 5, actually, which is not too bad. But what we do is we commonly merge master into everything, either manually, or one of the cool things also is that anytime you try to deploy a branch, Hubot's going to auto-merge master for you. We actually taught the robot how to merge code, which is pretty nice. But yeah, we're actively working on a whole bunch of things. We've got a whole bunch of pull requests in flight. And the idea is that we're able to isolate things to smaller change sets, right? It's the whole idea of sort of ship early, shipped often, rapid iteration. And we do that with our Puppet code as well. There's no such thing for us as a testing branch where you have, some unknown numerous sets of changes that are kind of just floating around that hopefully someday get merged in production without breaking it. We're also big on the chat ops train. I guess we started that train. I don't know. Like I mentioned, 202 employees. Everyone has access to Puppet, full write access. We trust all of them with that access, right? We're not going to try to limit anyone in any way. And as it turns out, when you give people that opportunity, they can do amazing things. So the list of roles that I've aggregated today of people inside GitHub who have actually touched production Puppet that you would never think would touch production Puppet, including enterprise sales staff, our GitHub for Windows developers, our support team, front-end designers, right? They've actually shipped meaningful improvements. For example, the WebKit developer up there actually wrote all of our support for deploying Puppet on Windows internally. None of our manifests worked on Windows until he sat down and just did it. Every Puppet run also happens in chat. That's invoked with a simple command. You just tell Hubot, run Puppet on this host, or no op Puppet on this host, enable Puppet on this host, disable Puppet on this host, change this host to a different environment. That's all easy. More importantly, though, is all Puppet output goes to chat, right? And sort of the consequence of that is that everyone can see everything, and because it's in chat, everyone can do anything with it. We trust all of our employees, and a lot of people now inside the company are getting really interested in sort of our operational space, whereas before we haven't really seen that. And I think the reason for that is that ChatOps allows you to have sort of hands-on learning by accident. People can just idle in the room, they see how you work day to day, and they can quickly build up this sort of almost tacit understanding of, oh, this is how I make a Puppet pull request. This is how I deploy the Puppet pull request. Here's how I test the Puppet pull request. Here's how I merge my change in, because all that's happening all in chat where everyone can see it at the same time. It also eliminates a lot of disruptive questions, especially when you're onboarding new employees. No one has to ask Did that Puppet run finish yet? What branch are you running Puppet on? Right? These are the questions that we're trying to avoid. So let's talk about the future of Puppet at GitHub. What's coming down the road, right? What's exciting? So first of all, Puppet 3x is a big one for us. We want to get onto it. We want to get back in line with upstream, particularly because, as most of you know, Puppet 2.7 open source is end-of-lifing next month. So as it turns out, upgrading a really large old code base from Puppet 2.7 to 3.0 is really hard, just like it was from 2.6 to 2.7 and 0.2.4 to 2.6. So the approach for this is often not great. It often means a separate Puppet master and testing all of your nodes against it repeatedly until you finally have everything in place, and then having a flag day. Not the most fun endeavor. And the crazy thing is like when I think about it, we were actually talking about this last year at PuppetConf when we first brought up this discussion internally, right when they were getting ready to release Puppet 3.0, was how are we going to do this? We still haven't done it yet because it's a hard problem. We're still trying to push forward with that. We're actually setting aside some time, I think 2 weeks in October, we're going to have a little hack house and try to get this upgraded. But in the meantime, Sam Kotler and myself actually are going forward, from what I understand, going to be the maintainers of Puppet 2.7, and we're going to be backporting all security fixes back to the 2.7 branch to keep that alive. So those of you running 2.7 in your environment still have security fixes and bug fixes coming down. We want to be on 3.2 by the end of the year as well, which will be a big improvement for us. We also want to eventually move to Ruby 2.0. We're still on Ruby 1.8.7 as packaged by our system providers because more, faster Ruby. And we'll get this for free, actually, when we move to Puppet 3.2. That already has the built-in 2.0 support. Though, talking to Sam, it sounds like we may backport 1.9.3 and 2.0 support to the 2.7 branch. We'll see how that turns out. We also want to get mcollective in place. We've actually had it in place before, but we haven't really taken advantage of it a lot in our infrastructure. And the reason for that is that we have this repository called Github Shell, right? It has all these shell scripts that we use to manage all sorts of different functionality inside the context of our environment. So like the mcollective story has been one of mostly, in a lot of cases, people asking why. So I've kind of referred to this as the story of Github Shell and the wonders of SSH in a for loop, which is how we do a lot of automation outside of Puppet right now. And the crazy thing is that it actually works surprisingly well. And that isn't to say there aren't a lot of really cool things about mcollective. I love mcollective. I love all of the concepts behind mcollective. And I think it's going to be a part of our stack in the future, but it is oftentimes hard to convince people that when you've come this far with Bash and SSH that you need a tool, for example, that requires MQ brokers and a daemon on every server, and then a client to talk to all of that stuff via the message bus. It's a hard argument, right? We're also going to be introducing even more PuppetDB tooling, so sort of in the vein of the NodGeosDB and Filtergendb stuff, which, correct me if I'm wrong, James, but I think we also want to get NodGeosDB open sourced at some point so folks can start using that. So it'll be pretty cool. Because waiting for multiple runs for like convergence is really terrible, actually. We've written all sorts of things like this. So one of the things I'm also working on for gPanel right now, talking to some folks today, is like, say you have like a cluster of Elasticsearch servers, and you're in an environment, I don't know where this environment might be, definitely not our data center, where you can't use multicast because your network is a layer 3 network. And having a list of unicast IPs populated through exported resources is kind of the worst experience imaginable, actually, because you have to run Puppet on A side, on B side, on A side, on B side, and then finally everything's convergent. You can restart the nodes again. So what we're adding to gPanel, we're kind of, let me get to this. I got a slide for this, I think. So we're going to use PuppetDB API, gPanel integration. So this concept of like data bags, right? It's like it's a loaded term. No one really knows what it means. And a lot of us kind of like sometimes scoff at the chef community. Oh, data bags, how awful. But at the end of the day, it's actually a really cool concept for a lot of things. So we're starting to use gPanel for some of this stuff, where you have like this notion of clusters, for example, in gPanel, where I can say, gPanel, give me the IPs that are actually applicable to this cluster, this Elasticsearch cluster, this Memcache cluster. And I can go ahead and pull those down. I don't have to wait for convergence across multiple runs. I let my inventory store decide sort of what the state of these things are. The other one we've talked about is bring back the idea of node search, which is another really, really cool tool inside the chef community. You can get some of this stuff out of mcollective, but being able to do it inside the Puppet runs themselves, I think, will prove itself to be pretty powerful. And the whole point of this, of course, is to steal good ideas from other tools because they're good ideas, regardless of what our thoughts on the other tools are. So some closing thoughts, right? If I had to sum up a few of my ruminations over the past day or two or month or two, first one is that all software is terrible. I'm sure all of you know that. All software is terrible. There's one, I stand by this. You can quote me on this. There is one piece of good software that has ever been written, and it's HA proxy. One piece of good software in all of history. All of it, besides that, terrible. There's another quote that I think about a lot in terms of keeping things simple and predictable and avoiding sort of these weird, complex, like theoretically it's more highly available, except for when it fails, and then it fails really, really hard, pieces of software. And that's that no software is better than no software. It's actually a really deep thought, right? If you have things that are simple and that break in understandable ways, that means you can fix them in really easy ways. Even if it means 5 minutes of downtime, it's a downtime that you understand and that you can mitigate. Whereas if you're using these complex pieces of software that they're starting to come up in a lot of other places in the world, you basically throw a lot of money at someone and hope they can fix it better, which is not a good place to be in. Not many of us are going to be experts in Raft or any of the other crazy consensus algorithms. Think about this one a lot. The other one, coming back to the point of tooling and stealing tooling from others because it's a good idea, is that, right, if you think about it in the context of like plumbing in your house, right, no one cares about the implementation of the plumbing. It's actually kind of gross. So what they care about is the porcelain, right? And that's to say it's the same thing with tools. The reason we focus so much on chat ops inside GitHub is that we care about how you expose things to users, how interfaces are friendly, how easy it is to understand versus all the implementation details behind it. You can write the most amazing technical tool, and I still won't care if it's a horrible experience to use it. So write some damn good porcelain. Now, who knows who this is? Anybody know who that is? He's kind of blurry. So this is Rajek, right? We talked about him a lot today. He never likes to talk, so I'm going to embarrass him right here. He's kind of in the crowd right there. So he is, again, normally not this blurry. Also not my brother, just so you know. This is the 3 times so far at this conference alone I have been called Rajek. He's a nice guy, but I'm not Rajek. You should really, really buy him a lot of beer. We all owe him so much for the work he's done in this community. So if you guys want to give him a round of applause, like forget me, like applaud him. It looks like we've got maybe 5 minutes for questions. I want to put this up in case some of you are interested. I've got the link to my talk up there. But if any of you guys have questions just about how we do anything with Puppet or operations at GitHub, there's a mic right there. Feel free to come up and just ask. All right, cool. You guys are making it easy. Oh, you got one? Come on, go. Yeah, do it.
So you say that everyone is React master. Do you do any kind of testing between moving modules?
OK, so I'll repeat the question since it didn't make it into the mic. So he was asking, since everyone has commit access to GitHub, do we do sort of any testing between moving modules from development to production and so on? Yeah, that's all hooked up into our continuous integration setup. He will obviously never deploy a branch unless it's past specs. We also, the sort of culture around GitHub is that no one really tries to commit to master. We try to do everything via the pull request model, right? Which is to say, once you have some sort of proof of concept, you submit a pull request, and everyone collaborates and discusses it from there. We haven't really had any issues. Typically, when people roll out something that's broken, it never really rolls out to a server, right? It's caught by the testing, and it's just held, and someone's like, yo, the build's red, let's fix this. So it hasn't proven to be a problem, really, in practice. Anyone else? Yeah. Yeah. So as far as our continuous integration goes, it's certainly not as robust as we'd like. It focuses primarily on sort of the unit and behavioral testing side of things. We don't have as many acceptance tests as I would like. We use Jenkins and a library that we wrote called Janky that sits as an API on top of it. So our whole workflow is that commit goes up to GitHub. There's a post receive hook that fires a post request to this URL. That triggers the build. When the build comes back, it sends a post request back to the GitHub commit status API, which says this commit passed or failed CI. So that's the whole chain. Janky is open source, so you guys can certainly look at that and use it. That's what our whole CI system is based upon. Cool. Well, thank you, everybody.